Welcome. So in this video we're going to discuss the following problem. Two quadratics are given below. If AB is minus 4 and we know something about the product of the roots of P and the sum of the roots of Q, what is A? So the first thing that comes to my mind about this problem is the quadratic equation. Because the quadratic equation will tell us the roots, and also part of the quadratic equation will multiply a and b together, and we know the result of a and b, it's minus 4. So let's take a peek at what the quadratic equation gives us. So first, minus the middle coefficient, so we would have for p, x equals a, and then plus or minus the square root of minus a squared, which is a squared, minus 4ab. And then that's all divided by 2a. So this tells me that x is equal to a plus or minus the square root of a squared plus 16. That's our simplification that we can make. ab is minus 4, so minus 4 times minus 4 gives us the 16. We can do the same thing with q. Let's try it. So over here with q, if we want to find the roots, we can again use the quadratic equation. We get minus b plus or minus the square root of b squared minus 4ab, all over 2b. So this is the same as, given what we know in the question, minus b plus or minus b squared plus 16 under the square root, all over 2b. Now we can use the part of the question that tells us about the sum and the product of these roots. We found the roots. There's 2 of them for p and 2 of them for q because of the plus or minus. So let's try this out. Let's first write down the product of the roots of p. So that would be a plus, we'll start with that one, a squared plus 16 underneath the square root divided by 2a. And that's all multiplied by a minus a squared plus 16 under the square root all over 2a. And this is supposed to equal the sum of the roots of q. So here we would write minus b. Let's write the plus first. Square root b squared plus 16, all divided by 2b. And this would be added to minus b minus the square root of b squared plus 16 all over 2b. Okay, now let's see if we can play the simplification game. Let's try to get this into a little bit of a nicer form. Looking on the left-hand side, let's notice we have a difference of squares. It's a plus some number multiplied by a minus the same number. This is what we call a difference of squares. So let's write this down. We have a squared, and then the difference of the other number, a squared plus 16's square root squared. So that's our other number that we have to take the difference of. And on the bottom, we have 2a multiplied by 2a, making 4a squared. Let's take a peek at the right-hand side. So on the right-hand side, we can simplify plus b squared plus 16 under the square root and minus b squared plus 16 under the square root. Those two go away, and we are left with a minus 2b on the top and a 2b on the bottom. So from here, on the left-hand side, we have a squared minus a squared, and just a minus 16 on the top divided by 4a squared on the bottom, so we have minus 4 over a squared. And on the right, it's just minus 1. So we can finally write down all the possibilities for a squared. It's just plus or minus 2. So a tiny little extension or challenge to discuss with this problem. The roots that we are looking for in the quadratic equation P have a special name. I'll let you pause the video now and think about what that special name to those roots might be. I'll give you the answer in a moment. Okay, so the two roots of the quadratic equation P are the following. X is equal to 1 plus or minus root 5 divided by 2. The special name for this number is the golden ratio, or in the minus version, the golden ratio's conjugate. You can search all over the internet and find a lot of information about the golden ratio.